In this episode, we are bringing a short original story called Hidden Quest to life through 2D animation. It's a simple 4-scene tale designed like a picture book featuring a mysterious gallery hidden in a castle and a music-loving boy named Femi who sets out to unlock its forgotten treasures. You'll see how I used Unity to animate this story. And yes, the full interactive app is already built with voiceovers, page navigation, and read-along text all in one place. But in this tutorial, we are focusing on just the animation, so you can learn how to bring your own story visuals to life step by step. Hi, I'm Bayo, a software engineer and children's book author. I created this series to help storytellers like you turn your illustrations and ideas into interactive story-based game apps without needing to be a game developer. Now, let's open up Unity and get started with the cover page of Hidden Quest. The first thing we need to do is prepare our visual assets outside of Unity. To do that, I'll open up my raw illustration files in Adobe Illustrator. My illustrations were done using Adobe Illustrator, hence my use of this software for this step. For the background, I'm going to take out some of these assets, such as the clouds, that I would like to work with in Unity. So, I'll export this out as a PNG file. It's already saved prior to recording this, as you can see. The other thing we need is a sprite sheet of different assets from our illustrations. I'll make that 1920 by 1080 and move those other assets over. So that will be the cloud, title text, and so on. We don't need to move all the cloud assets as they are essentially the same, so easily reusable in Unity, but I'll do that anyway. We'll repeat the process for the other scenes. We'll strip the background of the assets we'd like to tweak in Unity by moving them over to a sprite sheet. Then, we'll export out both as PNGs with transparent backgrounds. We can now preview the exported PNGs to see what they look like. Great, that's what we want. With our assets prepared, next we are going to import them into Unity to work with them. For our cover page, what we'll need to do is create it as a menu page. This will be the page from which we navigate to the first page or scene of the story. So we'll have the title text and button here. Also, each page will have a home button that takes us back to the menu page. To create the cover or menu page in Unity, we'll start by creating a scene in our scenes folder. So right-click and go to scene. I'll call this menu scene. Double-click it to open. Zoom in and move it to the middle. The scene view in Unity is where we'll do our development. Next, we'll bring in our prepared assets for this scene. For the menu scene, we need the background and sprite sheet, so I'll drag both PNG files into the Unity Assets folder. The first thing you want to ensure is that the background sprite is single by changing it here in the sprite mode and hitting apply. Single means it should be taken as a whole texture or image that should not be split. For the sprite sheet, it's obviously multiple because it's a collection of different images. However, we don't want these individual images for the title text. Instead, we want everything as one. In other words, we need 6 slices from this sprite sheet. To fix that, click on the sprite editor to open. Now, click on each of the letters to delete all but one. Next, select that undeleted one and stretch it all the way to the last. So now we have 6 slices. Click the apply button and we can close the sprite sheet editor. In the assets folder, confirm that it's now 6 slices with the title text now grouped as one. So that's fine. Now, let's design our background. I'll right click here and I'll go to UI and I'll select the panel. I'll rename it as the background panel. In Unity, when you create a UI item for the first time, Unity automatically adds a canvas and event system to your hierarchy. The canvas is the parent game object for all UI elements in Unity. The event system is what allows UI elements to be interactable, i.e. respond to click events. We'll make some slight adjustments to the canvas as follows. First, we change this UI scale mode to scale with screen size. I'll use the HD size of 1920 by 1080 as reference since it's consistent with the sizes of our background images. Another setting is the screen match mode, which I'll set to 0.5 so that it scales proportionately along the width and height. Next, let's change the background color of our background panel so it's consistent with what we have in the actual story. I'll simply copy and paste in the hexadecimal value, then make it opaque by bumping up the alpha value. For the background image, we'll add a UI image as a child of the background panel. I'll call it background image. Drag over our background sprite as its source image, then click here to set its native size to that of the image, i.e. 1920 by 1080. Make sure the alpha value is 255 here. We don't want it to be transparent. The other thing that we want is our enter button. So go to the UI and add a legacy button. I'll rename it, remove the text element, and change the background's source image to the imported sprite. Set it to its native size, and then we'll just reposition it below. That's looking good, so we can save the scene changes. The next step is to animate our enter button. To do that, select the enter button and then go into the animation window. Mine's already open. If not, go to the window menu, scroll down to animation and select it to open the animation window. Again, select the enter button and in the animation window, click the create button. Unity pops open a window to our project's asset directory to save the animation. I'll navigate to the animations folder I created in there, then create a subfolder called enter button, and I'll save the animation with the name scale up down. Now, we can see it alongside the timeline in the animation window. Nothing is happening yet. One thing to note is that with this animation created, Unity has added an animator component to the enter button. Unity has also attached an enter button animator controller that was also created by default. In the project assets folder, you'll find the animation clip and the auto-created animator controller. The animator controller allows us to control the animation. However, we won't be using it at this point, so don't worry about it. So let's select our button again and continue with the animation process. What we want to do is animate the scale property of the button so it scales up and down. To do that, we add that property like so. Again, ensure the button is currently selected in the hierarchy window. With that, you can see the rect transform which corresponds to that in the inspector. The scale property is under the rect transform. The properties here are the various things that we can animate for this selected button. We are interested in the scale only, but you can have a play around with others. Let's drop this arrow. We can see the scale. Click the plus to the right of it. You can now see the same values here as you have in the inspector. Also, Keyframes have been added on the 1st and 60th frame since we are using a frame rate of 60 frames per second. At this point, we can preview the animation by clicking this button. Nothing is happening yet, as nothing has changed between the first and last keyframe for our button scale. To make changes, click the record mode button and the top of our timeline changes to red. Hence, every change we make to our button is now recorded and saved to the current keyframe. The keyframe holds the scale property at any particular time. So if I come to the halfway mark at frame 30, I'll reduce the scale to 0.5 for the X, for the Y and even the Z. Z doesn't really matter for 2D animations, but for the sake of consistency, I've changed it. If I hit this now, you can see it's looping. Next, let's animate the clouds. For our cloud, the first thing I'll do is change its background color. This way, we could vary its color from what we have in the reference storybook. To do that, I'll add a new panel and rename it as Ground Background Panel. Then I'll reduce its size and pick the same color as the background panels. Now, I can change the previous color of the background panel to a sky blue color. I'll simply copy the hexadecimal color of the static background from Adobe Illustrator and paste it in here. So now we have a bright sky which contrasts with the ground around the trees. So that looks good. Now let's animate our clouds. First, create an empty game object and let's call it clouds. This will be the parent of our cloud images. Next, I'll add a UI image, name it Cloud Image 1, then set its source image property value to one of the cloud sprites in our sprite sheets. Click Set Native Size so it's the same size as the image we imported. Now we can move it up slightly. We want our clouds to be behind the castle, so I'll move the parent game object above the background image in the hierarchy. Note that in the hierarchy, the game objects below are rendered on top of the ones above in the scene. Next, let's repeat the process for 2 more UI images so we have 2 more clouds. We can do this by duplicating the existing one. Next, rename to Cloud Image 2 and Cloud Image 3, move to the right, then change the source image sprite for the copies. Also, we can resize and reposition them so that they are at some distance from each other. I'll select this cloud, which is the parent, and set that to the center. Then we can reposition its children cloud images to the left. So Shift, select, and this, and we'll move those. Yeah, that's good. Moving all 3 doesn't change the position of the parent cloud game object, so that's fine. Saving and testing this, we should see our enter button animating while the clouds remain static for now. Select the game object clouds, go into our animation window, and let's create a new animation by clicking the Create button. Create a new folder in the Animations folder called Clouds, then save the animation clip in there as Cloud Move. For the animation, we'll simply be moving from left to right, hence the horizontal direction. This corresponds to the position X in the inspector. The property for this is the anchored position of the rect transform for each cloud image. So we add the property for all 3 clouds, one after the other. Once done, click the play icon button in the animation window to preview it. Nothing has changed, so it remains static. Next, open the drop-down arrow for each property, then hit the record button. Now we can change the position X for each of the clouds. We could select all three at once, then move the position using the Move tool. Test it as you do until you find the right fit. You may notice that the clouds are moving too fast, in which case we can change the frame rate. So let's slow it down a bit by changing the frame rate from 60 to 10. Test it out. It looks decent, so we'll leave it at this for now. The most important thing is to understand the concept of varying the frame rate for speed. Next, let's add the title text image and animate it. For our title image, it's a similar process, but this time around, we'll animate it in the vertical direction, that is, position Y. Again, add a UI image, call it a title text image, and set its image property to the sliced hidden text image we imported via our sprite sheet. Then set it to its native size. Move it up, we'll be animating it to move up and down. Select it in the hierarchy, go into the animation window and select the Create button. We'll save the animation clip as title move in a subfolder called title text. Next, add the anchored position property which is under the rect transform. Hit record and change the position Y value for any of the keyframes. We'll start from the middle keyframe at 30 and move it down a bit. Preview to see. For the last two pages of the hidden quest, we have a character named Femi that we are going to animate in Unity. To do that, I have here a sprite sheet alongside a reference. I have split this character into different layers in Adobe Illustrator, and you can also see the reference. I've also exported both as PNG files with transparent backgrounds. In Unity, I'll drag both of the files into my sprites folder. The sprite mode of the reference image should be set to single. Hit apply after changing. On the other hand, the sprite sheet should already be set to multiple, which is fine. Click the arrow to the side to view the individual slices. It's been automatically sliced. Click to open the sprite editor to ensure everything has been sliced correctly without any overlaps. We could change the pivot for a few of them if we want. For example, the next pivot could be set to the bottom center. The pivot determines the axis or reference point for actions like rotation. Once done, click apply, then close the sprite editor. Looks good. Create a new scene and call it page 4. Add a UI panel and rename it as background panel. Configure the canvas to scale with screen size and match properties. This is to ensure the UI scales proportionately across different devices. Next, add an image. We'll call it reference image. drag in the character reference sprite and set it to its native size. We should also reduce its opacity by reducing the alpha value of its color. Next, let's create an empty game object and rename it as character. This will be the parent of all our character's body parts. For this, I'll create several UI images and change the source to each of the body parts. Let's start with the head. Drag the sliced head sprite into the source and set its native size. Now I can move it up. Repeat the process for other parts of the body. To do that, simply duplicate the image, rename it, drag in the appropriate sliced sprite to the source image slot, set it to its native size, and reposition it relative to the underlying reference image. One thing to take note of is the fact that items below in hierarchy are rendered on top of those higher up. Hence, we'll have to reorder things in hierarchy to match the reference. We'll return back to this later. For the musical notes, we'll create another empty game object and rename it as musical notes. Next, create UI images for the note slide sprite, like so. So far, so good. Next, we'll reorder the items in the hierarchy. Again, the items below are rendered atop the ones above it. Using our reference gives us a good sense of our reordering process. Now let's see how this looks. I'll hide the reference, it's looking good. I can easily move the parent game object around or even scale it. Next, we'll group some of the body parts together. For our character, the next thing we want to do is called parenting, which is a logical grouping of game objects inside another. So in this case, we can have logical groupings for the facial parts, the body, leg, eye, etc. That way, we can easily animate them as a group where required. This will also require reordering as we saw earlier. Starting with the face, we'll create an empty game object, call it face group, then move the facial body parts into it as its children. This is what parenting is. Depending on our animation needs, we can always play around with these as we go along. So don't worry if you are unsure of any grouping. Some may not even be necessary at this point. So what we also want to do is get our pivots right. Let's save this first and we can make sure our pivots are right. For instance, for the left hand, if we try rotating it using the rect tool, it rotates about its center. The pivot is that circle in the middle of the selected game object, our left hand. We could change its pivot to define its axis of rotation. To do that, go to the sprite sheet and open the sprite editor. Select the left-hand slide sprite. You can see it's anchored at the center, which is not what we want. I can change that by easily moving that anchor, this ring or circle icon. I can move that anchor here, so that's a custom. You can see it changes to custom in the bottom left dialog. I could change it back to the center in the dialog. So you have two options, either manually move the pivot to where you want or use the pivot drop down in the dialog. Once done, hit apply and close the editor. With that, when I rotate the hand again using the rotate tool, it rotates about the custom pivot position now. It may not seem obvious at this point and perhaps not one to worry about at this stage. I find that you may sometimes have to experiment with different pivot points to get your desired result. Next, we'll start animating the body parts. For our animation, select the character in the hierarchy and in the animation window, click Create. Once again, the Save window pops up with the current directory of our Project Assets folder. I'll navigate to my Animations folder and create a subfolder in there called Character. Then I'll save the animation clip as Anim1. Again, notice that Unity automatically does the following. It creates an animator controller in the same folder, adds an animator component to the character game object, and attaches the animator controller to its source property. First, let's animate the guitar playing action starting with the left hand. With the character still selected in the hierarchy, select Add a property in the animation window. We are going to be rotating the left hand slightly to mimic the action of playing the guitar strings. So we'll add the rotation property of the left hand. Here, you can see the different children of our selected character. Select the hand underscore L, which is our left hand. The rotation property is under the rect transform component, like so. It adds a keyframe at the first and last since we're using 60 frames per second. You can change the frame rate here if you want. As with the previous examples, if I preview this, nothing is happening because we've not changed anything. It's still maintaining the same values between the first and last keyframe. Before recording, I'll select the rect tool and change the pivot of the left hand so that its rotation occurs about this point. This is temporary, so we don't have to do it in the sprite editor. Next, I'll go to frame 30, then hit record to start capturing any change we make. I'll zoom in a bit so we can see better. Using the rect tool to rotate, I'll move my mouse around this edge until I see the rotation icon by the tip of the cursor. And now, I rotate slightly and preview the change. That looks good. For the right hand, we simply want to animate it slightly, moving up and down. So we'll repeat the process of selecting the property of the hand underscore R. This time around, we need the anchored position which lies under the rect transform component. So hit the plus icon again to add it. Again, keyframes are added to the first and last, 0 and 60. For this, we only want to change the X and Y position slightly, as our movement will be in the horizontal and vertical directions. Move the mouse to frame 30 and hit the record button to start recording so we can capture the changes that we are making. I'll select this move tool and move the hand up or down. Adjust to fit, then preview. You may have to try this a few times until you're satisfied. Now, let's animate the guitar. In our animation window, select Add Property, select the guitar, and add its rotation property. Right now, the X, Y, and Z rotation properties are set to 0. Without recording, let's get a feel for what we want to do first. Should we move it down a bit? Or should we move it up a bit? It should just be a very simple movement, nothing complicated. Yes, it's going to remain the same because we haven't recorded. Now that we're ready to animate, let's hit record and adjust our guitar positions on frame 30. Make sure you're selecting the guitar image in the hierarchy. Now let's just move this slightly down. Now we can preview the change. It looks good, so we can stop recording, although we can still keep previewing it. That's about it for our simple 2D animations in Unity. There's a pattern to it, as you might have noticed over the course of the animations we've covered. The final animations involve the same process, even though I won't go into any of those. It's just a repeat of what I have taught you so far. So go ahead, give it a try. It gets better as you play around with it more. Thank you for watching, and I hope Hidden Quest has sparked ideas for your own stories too. If you found this helpful, be sure to like, subscribe, and hit the bell icon so you don't miss the next episodes where we'll dive into voiceovers, read-along text, and full navigation. Remember, your story deserves more than just a place on the shelf. It deserves to be experienced. Until next time, keep telling stories and let's bring them to life.